Hello guys, welcome to today's live. In this live, I'm going to explain some commands controllers, which are on-off controllers and also on-off controllers with the Deadband and PID controllers using the videos which were uploaded on the PLCgoods YouTube channel. Because during the last live, one of my friends asked me how PID controllers work. So in this live, I'm going to use our videos to have a short introduction for these types of controllers. What way you can find these videos, which I'm going to use them in this live. First, use your browser and launch PLCgoods YouTube channel. Then select the playlist sections. Here you will find two playlists related to our TIA Portal course. Let me select this one, TIA Portal course upgraded. If you scroll down the mouse, you will see this video. You will find this video, manual and automatic control tutorial, part 14 of 40. This video explains on-off controllers and also how PID controllers work, and also display the performances using factory I/O software. Let me come back to my playlist. And the next playlist here, TIA Portal course, our simple versions. Also here, if you scroll down the mouse, you will find 3 videos in this playlist related to controllers. I started with this one, Siemens TIA Portal, how to program on-off and PID controllers. This video and also the next 2 videos will explain PID controllers. Okay, let me share the video with you. Okay. The simplest way to control a process is a manual process, which an operator use some actions like opening a valve or opening an inlet valve or outlet valve for this water tank to control its level. It's very simple, and in this method, an operator needs to check the level of water continuously. For example, here the operator should be used these 2 push buttons to reach the water level to its desired level. But a simple automatic controller is on-off controller. In this video, you can you can see the performances of controllers and also learn some points about them. Now I'm gonna only show you an overall of my videos. Okay, on-off controller for this system, how it works. Suppose my process is to control the level of water inside a tank. My controller is a PLC, and in this course, I'm using CPU S7100. And we need naturally a sensor to detect the level. Suppose my desired level is 150 centimeters, but my sensor has detected my level is around 120 centimeters. So the error is a positive value. In an on-off controller, use this sign. And suppose if my desired is 150, but my sensor has detected my level is about 160. So this error will be minus 10. My controller uses this sign. When the error sign is positive, it will turn on its inlet valve, the inlet valve of the water tank. But when the error sign is negative, it will turn off the inlet valve, and it can also turn on the outlet valve. So on-off controller works based on the error sign on this diagram. Now let's see its performance. It has a problem. Okay, my desired here, as you can see, my desired set point is 50, but the current level is less than my desired level. So my controller has turned on the inlet valve. Okay, now let me open the outlet valve. The level start to dropping. But my controller tried to keep the level of water around 50 centimeters. But because of the fluctuation on the water level, the sensor values is changed for a moment. It will be about 50 centimeters, but at a moment will be less than 50 centimeters. And my controller is turning on off the inlet valve. So it will be damage my actuator, my valve. So how we can fix this problem? We can use the on-off controller with a deadband to remove this fluctuation. A simple on-off controller has this diagram. For positive errors, turn on the inlet valve, but for negative error, turn off the inlet valve. But as you saw, it has a problem for a water tank system. And we can solve it with a hysteresis, with a deadband. We need an on-off controller with this diagram. You can use our videos on the PLCgoods YouTube channel to learn how this diagram is working. Now let me show you its performance. During the video, you will see how you can write an appropriate program to write a program for on-off controller with a deadband. Now I'm going only to show you its performance. As you saw, now my controller is trying to keeping the water level at the set point, which is 80 centimeters. This controller solved my previous problem, which was water level fluctuation, and also turning on off the inlet valve simultaneously, which will be damage my inlet valve. But this controller has a small problem. It cannot keep the water level exactly on my desired level. So how can I fix this problem? So let's look at PID controllers, which its simplest form is a PI controller. How a PI controller works? PI controller is a constant gain which multiplied with the error. If the, for example, in this diagram, if the error value be plus 10, the controller output will be 20. Now let's see only its performance. During the video, we explained how you can write appropriate program using TIA Portal. Okay, now you can see the performance of a simple PI controller. As you saw, my desired set point is 80, but the current water level is this level. And my controller is trying to reach the water level to my desired level. Note that at the first, the inlet valve is open at around it's 100%. But when the current level reaches to my desired level, the inlet valve will be closed and the volume of water will be decreased. But P controller is a problem. Then in this video, you can see that I opened the outlet valve. My controller tried to keep my desired the water level at my desired level, but it cannot. Why? Why a P controller cannot keep the water level at my desired level exactly? And you will see error will be a difference will be appear will be exit between my desired level set point and the liquid level. Note that what's the problem? When the controller want to open the inlet valve, it has only a constant number. So, for example, suppose Kp is for example, the number 2. So it will be multiplied with the error. And if my controller needs to open the inlet valve, but there is not any difference between my reference and the current level, and the error will be 0, the controller output will be 0, and it won't able to open the inlet valve. So if my controller need to open the inlet valve to reach the current level to my desired level, an error should be appear here. At these conditions, the controller's output will be non-zero and it will be able to open the inlet valve. My friends, you can use these videos on our PLCgoods YouTube channels. During the videos, we explain the necessary steps to test on-off controllers and PID controllers. So how can we remove this problem? We can use an integral term. We can use PI controller. Okay, how this term work, integral term work? The integral term use previous errors. So instead of, so if my controllers need to open the outlet, the inlet valve, it's not necessary there is a difference between my reference and the current level. And if it be zero, my controller output can be non-zero using its integral term. All right, so the integral term will be solve my previous problem by using P controller. Here, during the video, we explained how this diagram is working. So also during the video, we explained how you can implement a PID controller in TIA Portal software. I'm skipping these parts. All right. All right. In this video, we designed an HMI with these PID controllers constants. My current set point is 150, and my current level is this, which my controller is trying to increase it to reach my set points. You will see that this controller can keep my water level inside the tank exactly at my desired set point. Okay, my friends, if you don't have any questions, I will stop this live. I will see you in the next week. Thanks, my friends, for watching this live. Bye.